Hi, welcome to the final session of the ESN Marketplace, lessons on best practice for fire safety. Welcome if you're joining us on Hoover, welcome if you're joining us on Zoom. In the usual fashion, please feel free to introduce yourselves in the chat. And yeah, if you've been to any other sessions, share any highlights. And yeah, it'd be really great to hear a little bit of feedback on this final session. So yeah, if you've particularly enjoyed one of the sessions, please do share. We'd love to hear. I'm gonna wait a few more seconds before I introduce, just so we make sure that we get everyone from Hoover, because I know that that can be a little bit slow, I think, for people to join. Okay, so I'm going to get started. As I said, this is lessons on best practice for fire safety. So while extremely rare, fire incidents and explosions have occurred around the globe, and they're extremely dangerous to first responders, the people looking after the batteries and the surrounding biodiversity, the fire service. So as the as the battery industry grows and as we increase the megawatts deployed and the battery density, it's obviously a critical issue to make sure we get right. So what can we do to mitigate and reduce the risk of these incidents occurring, and how can we make sure that when they do occur that we respond to these incidents safely? So in this session today, we're going to discuss some of the key challenges around fire safety for the storage industry. And hopefully touch on some examples of best practice, and we're also aiming to come away from the session today with some actions that we can take forward to improve the situation. To help us do that today, we've got Marek Kubik from Fluence Energy, Rian Atoon from DNVGL, and Charlie Pugsley from the London Fire Brigade. So welcome to you three, thank you for joining us. So I'd like to first hear from all three of you why particularly you're interested in the fire safety issue in the battery industry. So if we could come to each of you one by one, tell us who you are and yes, why you're particularly interested in fire safety. Could we start with Marek, then coming on to Rian and ending with Charlie? Sure.
Thanks, Sophie. So good afternoon, everyone, or if you're tuning in from another part of the world, then good evening or good morning. So on the advantages of doing a webinar like this. So I'm Marek, as I've been introduced, Managing Director at Fluence. If you're not familiar with Fluence, very briefly, we're an energy storage technology and services company. We've been around for about 14 years, so we have a long track record and experience in building and designing energy storage systems and products. Most recently, in summer 2020, we launched our 6th iteration, so 6th generation design, which is what you can see in the virtual background behind me based on the cube. I thought that was the easiest way of sneaking this in without having any slides. So why are we interested in safety? I mean, I think Sophie really touched on it in the introduction, right? It's in everybody's interest. Like the need for flex in energy systems around the world is massive to deal with the decarbonization challenge that we have, but we have to do that in a safe way. It's essentially a reputational issue, right? If the industry doesn't scale in a safe manner, that's going to call into question that whole growth trajectory. So really important that we design energy storage systems to be as safe as they can be, recognizing, of course, that it is high voltage electrical equipment. All high voltage electrical equipment carries risks. So it's a case of learning from best practices and continually improving the design. I'm happy to get into this as we get into the panel to sort of talk through some of the lessons and the generations of technology and how it's evolved and how that's hopefully ever increasing the safety of these systems, decreasing the risks, so that as we continue to scale 10x, 100x over the next decade or so, which is really the trajectory we need to, that we do so keeping those incidents very rare and you know, as rare as possible. So I think that'll do for introductory remarks, and maybe we'll dig into more in the details.
Thanks, Marek. Rian.
Hello, yeah, thanks a lot for inviting me. I'm Rianne from DNV. I'm stationed in the Netherlands, so I hope to bring some external perspective to the discussions today. So for you who don't know DNV, we're an independent technical consultant. We work on the technical advisory of new technologies, due diligences for investors or advisory on that. And my expertise is mainly focused on the safety aspect on that. Yeah, I agree a lot with Marek. For me, the storage system is the key to a successful energy transition. And basically, I don't want to introduce extra risks into the society. So I find it really important that everyone looks at the perspective of safety with a realistic view. So yeah, we really need to pay attention, but not overreact to safety. And in the Netherlands, I'm in charge of setting up a battery safety test facility together with the fire brigade. So also on this, and I think we're going to discuss that in more detail today, but sharing knowledge and learning is for me the key to overcome the challenges that we face. Yeah.
Thank you, Rianne. Yeah, really great to have you here, especially coming from the battery safety stuff that you're doing. Charlie.
Hi, Sophie. You probably won't be surprised to hear where my angle is in terms of safety. But first of all, I work for the London Fire Brigade. London is a global city of nearly 9+ million people, very multicultural, a wide variety of risk. My day job is fire safety, and I also work for the National Fire Chiefs Council in terms of looking at electrical safety. However, such is the concern around the rise of new technology and alternative fuels and energy storage systems that the National Fire Chiefs Council are working closely with academia and with the sector, looking for international learning and are looking at a dedicated resource to support this, because I think we're very much minded that we absolutely have to get behind innovation and supporting business, and the need for the environmental change and decarbonisation. But conversely, what we have seen previously on a micro scale, for example, with product safety, is with rapid innovation and a developing market and new technologies, sometimes the innovation runs ahead of safety standards, which is why for us it's, you know, it's not about preventing forward motion and making sure that, you know, that we don't support the innovation, but it's just about that safety isn't considered as an inconvenience and afterthought, because this has got the potential in the wrong circumstance to cause a large loss of life. And I think also large sites and energy storages could also affect communities or the environment as well, if because of the runoff from firefighting water and things like that. So it's real opportunity, but just being minded in terms of the challenges as well, just so we all consider it and work together.
Thanks, Charlie. Yeah, I think Rianne and Charlie both touched on some really interesting stuff there about shared learning, which I definitely want to come back to. But first, Marek, I wanted to ask you a little bit more about you said something about recognizing risk, but also being aware that, you know, that will always be there and reducing that. So could you perhaps go into a little bit more detail on that? How can we reduce the risk and mitigate events? But then also, yeah, could you explain a little bit more about what you mean about that risk always being there?
Sure. So yeah, essentially, if you look at a battery, right, going down to cell level, it contains a very large amount of electrochemical energy, right? That's potential energy in a form that, if it's released in an uncontrolled way, releases a lot of heat, essentially. And that is the case. I think probably one of the first things to talk about is perhaps a shorthand misconception I do hear, right? There are different types of battery chemistry out there. There's, you know, most commonly for stationary energy storage system at large scale, we're talking about two types: lithium iron phosphate, LFP, and nickel manganese cobalt, NMC. Both can fail in exactly the same way. There's a perception, and there are some merits and truths to, you know, the LFP chemistry being in some ways safer than NMC, but it's not a silver bullet, right? It doesn't solve the problem necessarily. If you have a electrical short circuit or a a physical one, right? If a nail went through a battery pack, that creates the short circuit and that heat is released. So really, the whole design of an energy storage system is about thermal management and the safety and control of that system. So it's there basically to charge and discharge on demand. That's the useful job that it does to help integrate more renewables to the grid, to manage constraints on the electricity network. But they all can fail in this mechanism. So it's a case of putting in the right mitigation tools. Well, first of all, there's preventing something from happening. It's actually trying to stop it from spreading, but in the worst case, containing and making sure that it doesn't spread further, right? So there are multiple steps. It goes beyond technology as well. And I think we'll probably get into that discussion because it's not just about the technology, it's also around how you design your site. Charlie was mentioning there a little bit about safety plan, what do first responders do when they get to site? So all of that is also really important in terms of thinking about the safety of an overall energy storage project.
Rianne, have you got anything to add on that?
Yeah, I think this is indeed an interesting discussion, because basically whatever energy source you're going to use to provide your energy, there is a lot of energy stored. So there is always a risk of an uncontrolled release of that. And that is even the case with pumped hydro storage, for example. I mean, a dam can break and you have a huge problem. So the key is to realize that you have risk and take that into account into your design phase already. And as Marek was mentioning it, there is no golden answer to if you use this battery, there's no issue at all. So in the design phase, you need to think about who is going to work with it, who is going to interact, which information is relevant for who. And that is not only in the technical and material, so the components, but that's also in the processes that you think about. And mainly, I think that's where the key currently lies, is in people and the interactions with it. So how you can have processes, but if no one follows them, it doesn't make sense. And it's new innovation is new, technology is new. So we have to get used to working with it. And yeah, I would expect, but Charlie, please elaborate on that you have a lot of experience with fires, but not a lot with the specific way of a battery fire develop. And you can learn a lot on a theoretical base, but you have to experience it in practice in how it works. So
yeah, Charlie, would you like to comment on that?
Sure, yeah, and I mean, first of all, I think it's really positive in the way that all panelists are coming together to see common themes. But part of the challenge from a responder point of view is, apart from the hazard compared to normal electrical distribution, while large-scale electrical distribution requires the expertise of those involved in managing it to isolate it and make it safe, with large battery arrays, there's always that thermal runaway or the residual risk after, if you like, you try to isolate it, in terms of if you have to interact with it. There have been a few high-profile cases on the news from around the world where people have been injured or killed. So the numbers are still very small, but I think it is that bit that we do have to look at the practical learning, and this is why academia absolutely vital, industry experience absolutely vital, and it's about recognizing that we're all trying to contribute to addressing the same challenge in order to provide the solution we need. But we do need to be open in terms of sharing that learning. And it's also, I mean, I mentioned London as an area. It's also, if you've got a very large site, notwithstanding, I certainly have no expertise in setting up these systems, but spacing between the battery systems or containers, for example. Obviously, if you're in a more dense urban environment, or you're trying to site it somewhere out the way, for example, or on a roof or in a basement, again, you're creating additional hazards that perhaps we wouldn't normally be used to. So it really is about trying to gather as much data and to then create an ongoing feedback loop, so that we can work with everyone to try and learn from that best practice. Because clearly, for the people dealing with the installation maintenance, I think, as was mentioned, the human factor is obviously a key point, but it's just making sure that we try and stay ahead, because I think it's, if you have a disaster, unfortunately, I think that can set back some really good work by the responsible players in the industry quite quickly, when it's not necessarily representative of, you know, what the rest of the industry is doing. But again, that comes down to why we need to be engaging with all and actually capturing that learning.
You're so right. It's so scary, isn't it, that just one bad player could potentially set us all back, and it's something that we desperately need to see the industry grow. You touched on something there, which I think Marek also mentioned, this idea that it's not just around the battery technology, but the wider system and how you design that as a system. Marek, do you want to maybe come in on that again? What does that mean, that the wider system? How does that affect your business?
Yeah, well, it's an interesting point. I think Charlie picks up on a lot of them, right? There's maybe like 5 layers you can think about, right? There's designing the system in an intelligent way to minimize risk wherever possible. And I'll cite an example here of what we've seen, and probably what the audience who follow the ESN will have seen through generations of technology if they've been in the industry for 5 years or so. We used to see a lot of projects that either had walk-in containers, so large 40-foot containers that you'd physically enter, or even buildings for putting batteries in, or more like data centers. The generation of designers moved on to try and eliminate those risks through intelligent design. So right, the cubes you see behind me, they're isolating a certain amount of energy capacity so that it's not meant to propagate between one another, right? So that's something that we've looked at very closely and tested, or in fact, actually DNV have tested and looked at in great detail. But the second is physically you can't enter these cubes anymore, right? You service them from the outside. So if you think about it from a first responder's perspective, right, one of the reasons you might need to approach a facility is to rescue someone, right, that they're trapped inside, something like that. With this design, you're at least significantly limiting that risk, right? Someone could still be injured outside, but there's no entering, right, a dangerous confined space. So you can basically leave it sealed and avoid essentially oxygenating it, right? You basically leave it contained. So that's what I mean by the design point. Then you get into the next stages of what, and Charlie mentioned this really well, right? The risk of this is reputational, and the challenge for the industry is the general public don't necessarily reflect the difference between a unproven tier 2, tier 3 battery that's never been used in a system before versus one that is rigorously tested and has a long track record, right? So using well-tested components that have been pre-integrated in a lab environment that haven't just been brought to the field and being put together for the first time, that's also really important. And then you get onto your protection systems, right? So layers of, there are a lot of those different ones. I won't go through all of them, but right, deflagration panels, gas detection, smoke detection, the ability to electrically isolate any individual cube, right? There are a lot of different layers of protection that you can put in to intervene before an event happens, to slow it down or to stop it. Then the sort of final 2 layers, right? Software, it's the monitoring side of things. It's being able to look at what's happening and detect an anomaly and use that to switch it off straight away, right? So integration of hardware and software is also really important, particularly as some systems are being built without those coming together from different parties, not from like an integrated perspective. Mm-hmm. And then finally you get to the site level, and Charlie touched on some of that stuff, right? How do you actually design your overall site layout for making sure that first responders have good access to the site? So that could be things like turning circles. It can be, spacing between the aisles. So for instance, if one of these cube doors behind me is open, that you have room to get past the door, right? That it doesn't block the aisle, because then you've blocked the egress route. So lots of these different components, right? You can see it's very multidimensional, but you have to think through all of those in series. And some of those, it's our job in isolation to think about, the technology side, but a lot of it is collaborative, right? It's working with the local fire authorities, the planners, and so on. Mm-hmm.
Yeah, you've got a really great list there of best practice. Rianne, I don't know if you think Marek has missed anything. This sounds like very comprehensive.
No, you're quite complete, Marek. Thanks a lot for giving the clear overview. So it's good quality components. It's then the BMS, the software layer, and the system design. And on the other hand, the mitigation part, so the containment, the suppression systems and ventilation that you can take. And then the third layer is to inform, let's say, the emergency responders properly, or have an emergency plan in place to think about the different scenarios and think about how to respond. And I think already by doing this, there's a lot to gain, because what I've seen, let's say in my experience, is just a lot of unawareness and not thinking about it. And typically in innovation, you're focusing a lot on improving the energy density, improving the power. And we're now entering a phase where we're really maturing the technology and really have the realization of thinking about safety. And one of the things to add then to Marek is also to think about the location itself. So for example, I had the fire brigade in the Netherlands mentioning to me at some point that they saw a storage facility on top of a flat. Yeah, that's basically not necessary. It's just purely from the perspective of probably a solar panel combined, solar and storage combined, and not thinking about, not have any thinking in place about what happens if something goes wrong and can we access it. And yeah, I think with that there's a lot to gain.
Yeah, and there was something else that you touched on there about the liaison with the fire service. Charlie, I was wondering whether you've had any particularly good experience, like what does good liaison with you guys look like? How would you like the battery industry to engage with the fire service in terms of, do you want to bring them in, maybe have site tours? What does that look like?
Before I just cover that, I'd just like to touch back on in terms of what's foreseeable. And I think Marek made some really good points about, the 5 tiers, sorry if I've got that wrong, but the safety, if you like, and the things designed in. But again, going back to Rianne's point about human interaction, there's always this bit that if there's a maintenance worker who's had a heart attack, or for example, or something happens, an event causes them to fall down, we've got, if you like, the moral imperative to try and rescue that person because that's somebody's family member. It might be that there's a fire in one of these things, and if we don't interact with it, maybe the power goes off to a hospital or a community, because we all know how stretched the grid is. So what might, in a certain geographic location, the failure and taking offline of that energy storage system mean for the community? So there are, I think, foreseeable circumstances where there may be a real drive for the fire brigade to interact. And I think because it is, in terms of the level of incidents as emerging technology and as it becomes adopted, there's still a huge amount of learning for us to take on board. And as I say, that's why National Fire Chiefs are looking to create, if you like, a dedicated role for perhaps a year or so at least, just to start trying to really give some focused time on it. In terms of interacting with the fire and rescue service, I think we would always encourage people, engaging with their local fire and rescue service, and hearing the examples from the Netherlands is really great about that partnership working, because it's some of those things that sometimes we're all in our particular worlds and we won't necessarily have the worldview or the experience of somebody else in terms of thinking about some of the factors. I'm aware of a fire in London a few years back where, while it wasn't energy storage, it was a solar array on the roof of a block of flats, and unfortunately that led to, luckily, no loss of life, but every single flat, 50, 60 families displaced with no home. So the impacts are quite profound for some people, and also in terms of the suppression or let it burn, again, I think if you look at a case study such as Buncefield, and again, I appreciate this might be sounding off topic because it was an oil refinery, but it just gives an example that there was a real tension between, do we let it burn and let the smog layer go and pollute Europe, or do we try and put it out and then potentially that enters the water table and contaminates drinking water for maybe the next 40 years? So you can see it's a real difficult choice for those in the position of having to react to that, which again is why there's sometimes not a clear position beyond yes please early engagement, but it's also understanding that particularly smaller fire and rescue services or more rural fire and rescue services may not have a fire engineer on tap, so they might have to draw one from another service. So it's just about if it's the last minute, as we do with not energy storage but other consultations, sometimes it's a bit late for us to actually give meaningful feedback.
Yeah, I mean, we've got loads of like interesting things there, all the way from design and then creating the site, all the way out to building a relationship with your fire safety service, all of which are critical, aren't they, to make sure that those are all in place. But I feel like we've got a really comprehensive list of best practice there. I wanted to come back to something that we touched on very briefly at the beginning. The ESN have put together some recommendations on best practice. One of the things on there we've suggested is having a major incidents register that is shared. So Rhiannon and Charlie, you both touched on how we share learning and make that open. Rhiannon, does a major incidents register feel helpful? What do you think about that? And do you think we need something else?
Yeah, I think that's a really good idea, and that's going to help the market. I think one of the key challenges that when we're talking about incidents, we're often talking about that specific incident and then potentially blaming the company or whatever. And I think we should keep away from that and really think about, let's say, what's the learning for the industry? Because when we have that open mind together, we actually can have an open discussion about these things. And then there's also something to gain for a company where something happens, because a risk is always a probability times the impact. So even if you have all the measures in place, you still can be unlucky that something happens with your system. So just have that in mind, and then it helps a lot. And there are two things to add from experience from the Netherlands is, one is that we see that it's for the fire brigade really important to know about where the systems are, because now there are specific systems, the smaller ones, neighborhood batteries, that are not compliant to any permitting or whatever. We realized that unawareness, so not knowing what can be inside a container or a system, that is really a risk. And the other initiative which I've seen that's really helpful is that we now start to collect the incidents with the electrical vehicles, compared also to normal cars, so that we get insight in, because we don't have the statistics yet, so we don't know yet what the probabilities are. And yeah, those kind of things can help us a lot, I would say. So there would not only be the incident itself, but also the near misses that I would say are really relevant here.
Yeah, and it's really interesting as well what you're saying about awareness with the fire service. It's exactly the same, isn't it, for the people working with the batteries, isn't it? That's where it starts. So quite simple stuff, really, that feels quite achievable. Charlie, did you want to come in on that kind of shared learning point?
Yeah, I've been fortunate to be looking at risk. Well, I say fortunate, it's never an upbeat thing looking at risk, crisis and disaster management, but having been immersed in that sort of field for the last couple of years, it really supporting Rand's point about it's very easy to blame a company or to blame a single thing, but normally there are a range of underlying bits where some true learning actually lays, or some other factors lay. And also, I think the point, while the focus here is on large-scale installations, because of the lack of data, I do think there is a value in looking downstream, if you like, at the smaller, to just sort of get the understanding and see what lessons there are there. Because otherwise, we're just waiting for it to happen. Not necessarily disaster, but nevertheless an event that it might just be commercially impactful rather than on a community or in terms of life risk. But I think if you do try and do that whole piece of from large to small and see where the common themes are and what the causes are, it would be surprising in some of our work in day-to-day in the fire service, things that you would think are foreseeable. You know, we had a domestic oven once where apparently it's manufactured where you shouldn't put foil in the bottom. And that's something that people would do every day. And that's, again, it's off track. But it's just an example of human behavior that if you just think, you know, actually people do this kind of thing. And while coming to Merrick's point about those controls and systems, I think you can eliminate a lot of that. It's also just, well, actually, if somebody's going to stick a energy storage system on the roof of a block of flats, then to me, they've probably not done too much thinking.
Okay, so I mean, moving on from kind of sharing learning, how can we take that into the next step? I'd say is like producing guidance and even more so standards. So we've got quite a few questions about standards in the chat. Marek, do you want to come in on what you feel about the standards in the UK currently?
So I'll turn it maybe to DMV for sort of expertise on specific standards, right? You know, there aren't so many, particularly with respect to say fire safety, that are, should we say, a British standard, like, you know, a localized one, right? You generally have IEC standards and you have UL standards, and there are several that are, I guess, popularly used. Like our systems are designed for UL 9540A, having, you know, a favorable result under that, which is basically a non-propagation test. You know, it goes right from cell to system level, right? So there are different standards at cell level, module level, and then the UL 9548 is a unit level test that basically says, okay, if you've got a whole rack, you know, having a thermal runaway, that it doesn't spread to the next one. And so the idea of, you know, the cubes behind me is that that's going to contain your event. And the block size, I know it's sort of pretty difficult to maybe get a sense of scale from behind me, but these are about 2.5 by 2.5 meters roughly, in all dimensions. So, you know, each one of these is relatively large, but it is about a fifth of the standard size of system we were seeing before, right? The 40-foot container that maybe a lot of people are familiar with, right, for the previous generation design. So already there, you're limiting propagation quite significantly. So that one is important. But the challenge we have here, I guess, is, right, all of these standards really are advisory. It's right, if the employer asks for it, then you know, and it's a criteria, mandatory criteria, you have to design for it. But quite frankly, you can cut corners, right? There isn't a regulation that requires the employer to take all of these standards and say your system has to be designed for this. Another one, right, the two most common, and actually it's because the US in particular has been leading on this, are the NFPA standards, National Fire Prevention Authority in the United States. And those are NFPA 855, which has some specific rules. Partly it's an all-encompassing standard, so it's not just about the hardware design. It comes down to things like the spacing philosophy, the emergency response plan for the site, right? There are owner obligations there as well. But the other one is NFPA 68, and that is around deflagration venting. And so coming back to sort of those lessons learned, what we have seen, and I think there are really good you know, shared lessons from the US and Australia, where we haven't had that good visibilities into sort of the South Korean market and in China. But where those rare events do occur, the lessons from them have been adapted into this next generation of design, right? So for instance, gas detection is something that we're putting in all of our systems, so that if there is any off-gassing, which is you know, essentially a symptom of thermal runaway, the electrolyte will produce flammable gas, that's detected and it can be shut down early. But in the worst case that there is ignition of that it's directed upwards and not outwards, right, to protect life. And that, again, you can see behind me, the panels on the roof are deflagration panels. So we put all these in, like we take a very high bar to safety. But in the UK, there isn't actually a requirement that you have to do all these things. So it is possible to design, of course, a system cheaper by not installing sensors and safety and monitoring and deflagration panels and so on. But at the moment, I guess it just becomes more of an insurance risk and a reputational risk, rather than it means you can't get your project built. Now, personally, I think that should change. How it should change, that's you know, a question maybe for my colleagues on the panel.
Yeah, it's a really good question, Marek. Brianne, do you have the answer?
No, sorry, I don't have the answer. But I think one thing to realize is that, because I hear a lot of people say, oh, I just comply with that standard, so my system is safe. And I think one of the key things to realize is to understand, let's say, what a standard is and what regulation is, and how they fit together. Because basically a standard is an agreement between the stakeholders about a product or a system or a service. So basically it's a consortium of people that share their experience and make a list of things that you can, or recommendations, or how to improve your system. And the key challenge with storage systems for me is that every storage system is different. So there are different use cases, there are different designs, as Marek mentioned. Some are only accessible, most are, as Marek is saying, we also see the trend of smaller systems that are only accessible from the outside. But still there exist systems that you can enter from the inside. So it's not like, oh, I integrate a deflagration panel, check. You need to think about, okay, I did, for example, the UL 9548 testing, so about the fire propagation. I learned about what can be released in my system, and now I integrated that in my system design, because in my system I expect that maximum explosion risk. So each system requires different things. In the end, the key is to do a proper risk assessment and to include in your system design, your situation. Because what Charlie also mentioned, it matters a lot. If my system is in the middle of nowhere, I might consider a situation where it's controlled burning. Well, if it's next to a flat, I won't. So that just requires different mitigations.
So it kind of sounds like any kind of standard or guidance is never going to be a tick box.
It's never going to be.
It needs approval by someone really qualified.
No, it never means just a checkbox. So you always need to add your experience as a system developer, of course, and the people around it. And the next thing is that you also have to realize that regulation and standards are always going to be behind technology. So just having, and in the Netherlands, for example, we see now a regulation is in the making for a set of rules, or how to, what you need to do with a storage system. But until that moment, it's mainly the building codes that requires you to design a system safely, and then you can do that by following a specific standard, for example. So there's a lot of interpretation there still, and working safely, what does it mean? That is still not yet a set of checklist items. And
I think sorry,
it will take a while to get there. So
I think we're in a similar stage in the UK in a way. The BEIS Health and Safety Governance Group, which Maddie, who runs the ESN, she is part of, they've been in the process of putting together some guidance for large scale storage. So I think we've kind of answered this a little bit, but I was just wondering, what do you guys think about BEIS producing some guidance? Do you think that's going to be enough to assure the public and the fire service and insurers that that sites are safe, or do you think we need something more, and what does that look like? Charlie, coming to you first from the fire safety perspective.
Sure, I think it's really good if BEIS, if you like, the regulator of that space potentially are taking a lead role. But I do think it needs to be a partnership between all of those involved, because going back to Rianne's point, the pace of change and the innovation is, you've got to have agile standards or guidance. You also have to have ones that are realistic, so that things that testing a component just in the laboratory isn't the same as when it's fitted in an installation. So again, is the test, and again, something I've seen across a range of product safety issues, are the tests and the guidance actually relevant to that installation? Again, back to Marek and Rianne's point about different sites, you're going to have very different risk assessments. And even there was something in the Q&A about the environmental risk. Again, if we go to a petrochemical site, you would expect to see interceptors, things that can collect, if you like, overspill built into the site, and bund walls to for containment. But again, that would be probably specific according to the technology and the site and everything else and the local conditions. So I think there is a real risk if you try to have one size fits all, particularly for a market like this. arguably going to be a constraint rather than a benefit. So I think it's there's a real benefit in terms of having outcome-based standards guidance that are actually, and where there is participation, where people, again, it's not about hampering industry, it's about making sure industry are a full partner along with the government to make sure that we get the best for our communities.
Marek, would you like to come in on that from your perspective?
Yeah, I mean, look, I'll agree on both fronts, because Rhiannon talked about, right, it's not just tick boxing, right? Because it is very easy to do a tick boxing exercise and say, yes, this is safe, this is not. But I also completely agree with Charlie. It doesn't make a lot of sense so the challenge with government, we know they're not always the quickest. So the agility point is really important. Like, the industry is still evolving very quickly and things change every 6 months. So by the time a list of standards come out, there probably are better ones, or updated information that we can work on and rely on. So I think it's a combination of the two. You need to have some guidance, and it may be different, right, for the smaller systems versus the large. It may be different for the EVs versus the large sort of stationary storage that's megawatts or hundreds of megawatts of scale. Probably can't say too much more than that.
That's all right. I think we have time for some questions, and there's been an interesting one which perhaps takes us away from discussing like the standards and the guidance and the best practice, but more so on the reputational side. As I said at the very beginning, these incidents are incredibly rare, but obviously there's this fear lingering. What can we do as an industry to what was the question? Reassure them of the safety of the batteries when we have really given the due diligence to making sure that the sites are safe. Does anyone in particular want to come in on that first? Charlie, go for it.
Sorry, my silky IT skills, they're reaching across the keyboard. I do apologise. If I pretended I was somewhere else, that would explain the delay. I think partly talking about public confidence is a tricky one. I think being part of the post-Grenfell era and the terrible tragedy that was, I think, aside from the criticism of the fire service, to hear that the building sector was described as being broken by Dame Judith Hackett. So it's quite a tricky one, because I think in the public mind, certainly in this country, there may be a distrust of where such projects and everything else, which is why I think in terms of it would be about open demonstrating, because while events might be rare, again, it's about that low frequency, high impact event that could really impact on the community. And I won't labour the points I made earlier, but I do think there is the bit around, if you can show that you have that open learning forum, it's not just like a closed shop, like part of the building industry. Again, without going into the detail about how buildings were constructed and signed off, there was a lot of criticism in the inquiry. I think that's very openly known. So I think if you can demonstrate that you are doing everything reasonably practical to actually identify and mitigate risk and learn from it and evolve, I think that puts you in the best position possible. Beyond that, I don't have any other useful suggestions.
Does anyone else want to come in? Sorry. Rhiannon, you threw your hand up first.
I just skipped the digital part. And I think it's a really interesting point that you're making, because it's always the difficulty that I have myself as well in the communication. Because on one hand, you want to show that there is a risk and a significant impact. So I want to show a movie about a cell that explodes, to show, let's say, that someone should be aware and should take care. On the other hand, I don't want to, it is a controllable risk. It is a risk that you can mitigate. So there's a balance between making awareness, but not, let's say, influencing the public opinion in that way that it's that no one wants it anymore. And that's a tricky balance. And so I think what we were just mentioning in the discussion before, it's to show that we are working on the topic of safety and that we're, let's say, taking effective safety mitigation measures, and to be open about it. I think that's something that really is going to help. And on the same time, I would say there's also a role for the government to realize that if you're investing in the Netherlands, for example, we're investing billions of euros in the energy transition, but you also need to realize that you need to do significant research on the safety aspects. And I think there's also a role for the government to, let's say, allow the triangle with industry, knowledge institutes, and the emergency services to think about it and think about how you can do that together.
Yeah.
Go on, Marek.
So to round this off, yeah, I'll approach it slightly differently, because I mean, as a technology provider, you know, we provide energy storage products to the developers or asset owners, right? So our engagement directly with the general public that's sort of a step removed from what we do. Where I mean, I think the answer is the same in any case. It's going to be engagement, education, and training. But we do that most proactively with our customers. So we have, as part of like selling the product and then coming and commissioning it, there is a documented training program that's part of that covers everything from system operation, orientation, maintenance, but it also very importantly includes the first responder training as well, right? And it's not generic, it's then adapted to the project and site specific requirements. So active engagement on that. I think in the US, I'm not sure if we're doing this in the UK yet, but certainly I think it's a good idea. We're rolling out as well like training programs specifically for first responders, because I'm sure Charlie would agree with this, right? Whoever we bring to site, even if we do train them, they're not necessarily the people that are going to come to site on the date of an incident, right? So making sure that that information can be disseminated and accessed by the whole first responder community is, I think, really important, because you can train one person, that doesn't necessarily help solve the problem. The next layer of engagement then, right, and usually we're getting involved when a project already has its business case, its land, grid planning approved, right? But the planning stage is usually where there's a lot of that engagement with the community, particularly with the planners and local authorities, right? So we do support those efforts quite often with information on the systems, answering questions of those planners, right, answering questions of the local authority. So in each of these cases, right, there's work to be done, but usually we're getting involved more so once the project already has planning and that hard work has been done. So I feel I can only sort of answer the back end rather than the front end.
I think you might have sneakily answered another question there about at what point in the development of a project should the fire services get involved. So it sounds like planning is the right stage, not already when it's being constructed. Charlie, would you agree with that?
Absolutely, but I also think, particularly if you're more likely to have these in rural areas, it's about making sure if you knock at your local fire station door, it's about making sure that you're getting through to the right people, because the person on the fire engine might not be the person who deals with some of the planning. So it's just making sure that we get connected to the right people. And as I say, about allowing sufficient time for that engagement, because as I say, in London, while we've got a deluge of work, we do have a range of specialist engineers working with us, whereas other services, there might be a shared resource. So absolutely, earlier the better.
Awesome. So we are coming near to the end of the session, but I'd like to ask everyone one final question. I promised at the beginning that we'd come away with some actions that the ESN can take. So yes, what can the ESN do? What can we push government to do? What are your favourites, so to speak? So in the backwards order from how we started, Charlie, what are your the actions that you'd like to see?
So I'm going to steal some of the points from my fellow panelists, so quite unashamedly, but I do think that while we're focusing on large energy storage systems, Rhiannon's point about looking downstream at smaller and other related technologies to get the learning. And then the other point is just to reiterate about that, be it knowledge institutions or academics, industry and government, responders, let's be open and work together and make sure that we also look globally. Because although there might be different regulation and systems and setup, it is about why wait for it to happen here when there's learning elsewhere as well. And the final bit is about research and testing. The more we can, across the sector, support research and learning, the more we're going to know in terms of what we're dealing with.
Thanks, Charlie. Rianne?
Yes, thanks. I fully agree with that, Charlie. And for me personally, the knowledge sharing is one of the most important aspects. And that's both internationally, so globally, between, let's say, regions, countries, and experiences, as well as also across, let's say, the stakeholders. So what's the experience and understanding of, let's say, the developer, the one who needs to work with it, the fire brigade, but also the insurer and the government, and in all of this, for me, let's say, being open and realistic, I think that works the best. One of the comments was also, let's say, how to get support from local communities, for example. I think one of the most important things is just to be open and show what kind of safety measures you're taking. Because when you're closed, people don't know what you're telling or what you're not telling. And that gives a lot of difficulties. Yeah.
Thanks, Rianne. And finally, Marek.
Well, the prerogative of going last is a problem here, because I think I just have to repeat mostly what the other.
Sorry, I made you go first and last.
It's fine.
I also know how that feels, Marek.
we had a good phrase that was used. I think Charlie gets credit for inventing it here. Agile Standards. That I think is important, right? So I do think we're getting to a point where standards and guidance on this is helpful, but we need to make sure that it keeps up with the times. And I've seen some points in the chat there about insurance as well, right? That's the other reason as well, right? Insurers have a big role to play actually in these systems as well, because ultimately if developers, asset owners do not get insurance, or the insurance is very expensive, that also affects the viability of these projects. And there's not, I think, still a good understanding in that community about the differences in design and these standards and how that can influence things. Personally, I don't think we should be seeing systems built without fire suppression or without deflagration panels and all these things, but technically that can still happen. So firming that up helps reduce the chance of these events happening. The other 2 points I think are basically the same as my fellow panelists raised, right? So information sharing. One thing Regen could do, the challenge here is, right, fortunately, there aren't many data points, certainly in the UK, right? There's really, I think, only one major fire that I'm aware of in a utility scale storage system. So making sure we get the information from those events really requires some international collaboration, and maybe that's ESN, Regen working with the US Energy Storage Association, which we're also members of, the Energy Storage Island. Right, these sort of different trade associations probably need to work together to try and get enough data to be useful for using in this space. And yeah, it finally comes also down to the procedures, the design of the overall system, not just the product, right? So you can have a deflagration panel, but if we sell a product and then someone decides to put another cube right on top of the first cube, that's probably not a very smart design, right? You don't want your explosion venting up into the next unit above, and so it requires a full sort of system thinking, and that's a lot of different topics.
Mm-hmm. Well, thank you to all three of you. We've got an amazing list there of, I think, things that we can do. So trying to work more globally, trying to share learning more globally, and working out how we do that. And it sounds like it is time for government to think about creating a standard, and it's not going to be easy because it needs to be agile, but we are at the point in the industry now where that would be helpful, because we don't want someone to mess it up for the rest of us. And like Marek, you said, it's a systems thinking thing, isn't it? It's not just a quick fix where we can swap out one battery for another. It's thinking about the design of all of the stages, and then also engaging with the fire service, and that starts with awareness and all sorts of other things. So thank you so much for joining me, and this is the last session, so I also want to say thank you to our organisers. I've got Estelle in the room with me, and Hannah and Maddie. They've been absolutely amazing, so thank you guys. And also, of course, thank you to our sponsors, Fluence, Schneider Electric, Fries and Modo. Thank you so much for your support. This couldn't be done without you. And also, if you are really interested in what we've been talking about today, this is the kind of conversations we have at our working groups, and we have a specific working group looking at fire safety, sustainability. So if you are interested, please do have a look at the membership page and get in contact. We'd love to continue this conversation further. And finally, thank you so much for everyone for coming. And I hope you enjoy the rest of your Thursday.